Hey there. So I forgot how long of a section 1.4 is. So last time I said that the last video was the last video, but it turns out this is the last video in the section. Sorry about that. So this is problem number 11, section 1.4, and I am trying to compute the derivative using the limit definition of h of x equals x cubed plus 4x minus 10. So to do that, I'm going to follow the steps here. The function it was given to me. It's h of x. And f of x plus h means I'm going to take that function, and everywhere I see an x, I'm going to change it to be x plus h. So f of x plus h is going to be x plus h cubed plus 4x plus h minus 10. So let's see, x plus h cubed, that means x plus h multiplied by itself 3 times. Alright, and then I'm going to take a shortcut here. I mean, it's not much of a shortcut, but we've already done x plus h times x plus h so many times that I'm just going to skip to that part. We've done it twice already. X plus h times x plus h is just x squared plus 2hx plus h squared. So if you're not sure if you believe me about that, you can pause the video and double check it. Alright, and then I'm going to multiply this 4 through. 4x plus 4h minus 10. Now I'm going to multiply these two together, and I do that by first I multiply every term on the left by x, and then I'll multiply every term on the left by h. So if I do that, I get x cubed plus 2hx squared plus h squared x. Now I'm going to multiply it by h plus x squared h. Oh, that's cool. X squared, x squared h plus 2h squared x plus h cubed. And then I'm going to add everything else to it, plus 4x plus 4h minus 10. And I'll check to see if anything can be added together. Okay, so I have a 2hx squared right here and an x squared h. I think, yeah, that's the only one. So that, if I put those two together, that's going to be x cubed plus 3hx squared. Then h squared x. Oh, and actually it happens again. H squared x and a 2h squared x. So that's plus 3h squared x plus h cubed plus 4x plus 4h minus 10. Okay, so I simplified it. I've done that step, check. Now I will use that in my difference quotient over here. And actually, I should probably do that a little higher up. Okay, difference quotient, x cubed plus 3hx squared plus 3h squared x plus h cubed plus 4x plus 4h minus 10 minus the original function, and I'm going to use parentheses here. I will do that every time because it helps keep track of stuff, all over h. Okay, now I have to go through and simplify. So this minus, I'll change it to a plus, make that a negative, and that a positive. Okay, so this is good. I have an x squared and a negative x squared. So those are going to cancel. And then, okay, oh, all right, I have a 4x and a negative 4x. Those cancel. And then a negative 10 and a positive 10. So this entire like right side here, all of that got canceled. So I think that's kind of helpful. With that, we got, let's see, 3hx squared, let's see what's left, plus 3h squared x plus h cubed, let's see, plus 4h all over h. And I'm simplifying, I'm getting rid of all the h's. That leaves me with 3x squared plus 3hx plus h squared plus 4. Okay, limit then, so I know f prime of x is equal to the limit as h goes to 0, 3x squared plus 3hx plus h squared plus 4. Okay, h goes to 0. Well, that's going to go away, and well, that. And I'm just going to plug in 0. 3. Oh, sorry, I already did plug in 0. So when I plug in 0, these both went away, and I get 3x squared plus 4. Let's see what I started with. Yeah, so far that makes sense. Okay, let's do one more that's a little bit different than the other ones. Okay, so this time I'm going to not have like a structure, and I'm just going to do it from scratch. So j prime of x. So the first thing I want is I need j of x plus h. So j of x plus h is going to equal 1 over x plus h. And then the difference quotient, dq, that's going to be 1 over x plus h minus the original function, which is just 1 over x. And then all of that gets divided by h. So the top part, I need to add some fractions. The way I add fractions is I make the denominators the same and then I add across the top. So to make the denominators the same, I'll take the first fraction, 1 over x plus h, and I'm going to multiply it on the bottom and top by x. And then the second fraction, 1 over x, I'm going to multiply that by x plus h on top and bottom. So now I have x times x plus h both places, which is good. So I have, let's see, x over x times x plus h minus x plus h all over h. This is kind of weird, but just to like be clear here, I just changed 1 times x to be x, and then 1 times x plus h, I just made that x plus h, and then I combined the fractions into one fraction. So simplifying again, x minus h, that looks like it's x minus x is 0, so I get minus h divided by x times x plus h. And all of that gets divided by h. So then I do like old school fractions here, where I do minus h over x times x plus h, and then it's getting divided by h over 1. So cross multiplying, I get an h on the top, and then an h over h times x plus h, which is nice because these h's are going to cancel. And then I get 1 over x times x plus h. Okay, so I simplified the difference quotient. Now I know that j prime of x is going to equal the limit of the difference quotient. So limit as h goes to 0 of 1 over x times x plus h. So this is a rational function, so I'm going to just try plugging in h equals 0, and if that works, then I've got an answer. 1 over x times x plus 0, that's good. Get 1 over x squared. So this is a little different from the problems we did before, but the process is exactly the same. You find the difference quotient, you simplify the difference quotient, and then you take the limit as h goes to 0. So this is actually a thing that we're going to need to remember for the rest of this class, is that when you have the function 1 over x, the derivative is 1 over x squared. Pretty cool. Actually, you may have noticed I actually dropped a negative somewhere. So I was just looking at this thinking something seems a little off. So I had a negative h here and a negative h here. So actually this should be a negative h, which is nice. Let's see, so this would be a negative 1. Okay, negative 1. Still a negative 1. Yes, okay, so my bad. The derivative should be negative 1 over x squared. Let me know if you have any questions, and we'll pick up later in section 1.5.